Welcome to Zero Knowledge. I'm your host, Anna Rose. In this podcast, we will be exploring the latest in zero-knowledge research and the decentralized web, as well as new paradigms that promise to change the way we interact and transact online. This week, guest host Robert Habermeier and I chat with Pratyush Mishra about Arkworks, an ecosystem for developing SNARKs and developing on top of SNARKs. But first, I want to remind all of you to subscribe to the ZK Mesh newsletter. It's a monthly newsletter that looks at the latest in decentralized privacy-preserving tech, privacy protocol development, and zero-knowledge systems research. It's put together by myself and Mikera. Be sure to subscribe to get this delivered directly to your inbox at the beginning of every month. The next one comes out in a couple days. I've added the link to this in the show notes. I also want to thank this week's sponsor, Least Authority. Least Authority is a security consulting and product development company known for pushing the limits on how to build privacy-respecting solutions. They are a team of security researchers, open source developers, privacy advocates, and cryptographers. They are firm believers in the protection of people's privacy, but they also believe that privacy tech should be easy for people to use. Least Authority has developed an end-to-end encryption cloud storage product that minimizes the collection of any data related to its users. This is called PrivateStorage. PrivateStorage implements privacy and security by design, not by policy. It's based on Tahoe Laughs, an open-source distributed file store. The product is launching in the second half of this year. Please visit privatestorage.io to learn more and to sign up to be notified about its release. So thank you again, Least Authority. Now here's our episode all about Arkworks. So today, guest host Robert Habermeier and I are going to be chatting with Pratyush all about Arkworks. So first off, welcome back to the show, Rob.
Thank you, Anna. Glad to be here.
And welcome, Pratyush. It's also your second time on here.
Yeah, thank you so much, Anna. Yeah, it's great to be here. And looking forward to the podcast with the two of you.
Cool. So, Rob, you've actually been on, you're a two-time guest, but this is the first time you're going to be co-hosting with me. There are episodes that I can link to where you talk more about the work you do, but I think it's worth it for our audience for a quick intro to you. Who are you? What are you doing?
Well, my name is Robert. A lot of people call me Rob. I am the co-founder of Polkadot Network. I've been working in Rust building blockchain software for almost 5 years now. Yeah, that's all the important parts.
Cool. What you just described as some of your bio kind of explains why you're the co-host on this particular episode, because Arkworks is a collection of Rust libraries, and I thought it would be really great to have an expert here with me in talking to you, Pratyush. Now, Pratyush, you've been, the last time you were on the show, you were actually on the show for a whole conversation about the Zexy construction, and we talked kind of in detail into that. We've also, since then, we've done study clubs with you. You spoke at the summit, this past online summit in the fall. But I was thinking maybe you could tell us a little bit about where we left you with the Zexy curves to now. What have you worked on, and what is Arkworks? What's kind of come out of that?
Yeah, the last time I was on the show, I was, I guess, still a second or third year PhD student, so still quite fresh. But yeah, so my main project at the time was Zexy, which is a system for doing private computation in decentralized ledgers. And as part of that paper, we developed an implementation for our construction. And that implementation required us to, do all kinds of SNARK-related implementation. So we had to implement at the lowest level the elliptic curves and the finite fields. And then on top of that, we had to develop the actual SNARKs themselves and then write constraint systems for these SNARKs and then finally, implement the Zexy construction. So this code, we started developing it using an initial fork of Sean Bowe's Bellman library. So Howard, Wu, and I, we forked that code base to expose a few more knobs that we could fine tune for our construction. And that sort of code base has eventually, over the course of the next few, past few years, evolved into the Arkworks ecosystem. And so now Arkworks is an ecosystem for developing SNARKs and developing on top of SNARKs, so developing applications that use SNARKs. And it has seen a lot of contributions, not only by me and Howard, but since then a lot of contributions by students at Berkeley who've done an excellent job like implementing new protocols and implementing new applications inside the Arkworks ecosystem, as well as from outside contributors from Zcash folks, from Cello folks, as well as Alio folks. So like a lot of different people in industry have contributed to the Arkworks ecosystem.
I just remember we've done like study clubs on the Zexi paper. Originally, this was basically an academic paper, as I understood it, and there was an implementation, but it wasn't necessarily the focus of the work. Like it was sort of something that could be implemented. But now, since then, are you saying that you've shifted most of your focus just towards the engineering side of this to build out those libraries so that it's an implementation that could be used? Or is that something that was already there with Zexi that's just evolved?
Yeah, so I guess the Zexi specific component of that original code base was, I guess, not even like the largest part of that code base. It was mostly just, as I said, like the elliptic curves and the SNARKs and maybe the constraint systems on top of that. And then finally, we put together all of these, modular components, and we got Zexi. And the parts that were reusable for other research projects were these lower level components, the curves and the SNARKs and the constraint systems. And those are the parts that we have since developed further. I don't spend all of my time on it, but like a significant amount of time, me as well as a lot of other students at Berkeley, as well as external contributors, have spent in improving the code base. And yeah, now it's used not only in our research projects, but also by other projects in industry. So I think Cello is using the curves that we have implemented there, as well as I believe they're using a fork of our code base. So it's exciting that the work that we started, just to basically show that our idea in Zexi was feasible and, not just theoretical, that has sort of evolved into something that a lot of people contribute to and is now useful for a lot of people.
So coming back to that point that you just raised about like the practical versus theoretical, where do you see Arkworks fitting into that? Is it more something that you see people using later on when they're implementing protocols that have already been described, or do you also view it as a playground for work on the research phase?
Right. So I think, I guess the nice thing for like when you're working in the zero knowledge space is that these lines are often blurred. So for example, this is not my personal story, but what I believe, I think Sean Bowe said when they were started working on the Halo paper, was that he started implementing the bulletproof protocol, and then he noticed some curiosity about its structure, and that led to the whole Halo approach, which has since spawned a lot of research papers. So I think like this, research by tinkering with code is definitely something that is possible in the zero knowledge space. And I think our goal with Arkworks is to not only support, I guess, production-ish use cases, like towards the end of your research pipeline, but also during research itself. And I think we do take this approach like within our research projects. We try to accompany them with, like when we're writing out the constructions, we try to, have a map of how this would look in implementation land if, it's implementable. And often that translates, straightforwardly when you're actually implementing code. So like one of the goals of our code base is to make sure that, when you start off with a description in a science paper, going from that description, which is high level, to go to code shouldn't require too much thought on the part of the implementer. It should be easy to get secure and performant code. So yes, I think to answer your question, we do aim to support both kinds of use cases because it did originate as a research code base.
You sort of mentioned that it's not the only thing that you actually work on. What else are you working on right now as part of your studies?
Right. So I guess since the Zexi paper, what really that spawned was that, or what I found interesting was that it left two sort of open questions. The first was that in Zexi, or for the Zexi model to really work out, you need two efficient components. One is that you need to be able to do proof recursion, efficiently, because one of the key, components or ideas in Zexi is to recursively check some proofs of computations within a particular transaction. And the other one was, we are making SNARKs for specific computations. You don't want to do a trusted setup per computation, and so you want to be able to do just one setup and reuse that. So that sort of, these two questions spawned, my research in the zero knowledge space since. On this, updatable or reusable SNARK, I worked on Marlin with Alessandro and a bunch of other great authors. And on the recursion front, I've been working on some follow-ups to Halo, which we put up online last year. And I think there's going to be a ZK study club about that hopefully soon as well.
No, totally.
Yeah, and so like for both of these, we did try to implement our protocols, and we use the Arkworks ecosystem for that.
That actually, that's sort of a main question I have about Arkworks is what is it exactly? Like you're sort of saying now you've used it to implement some of the research that you're doing going forward, but like, is it a language? Is it I don't know, is it in an environment? Like, is it just a collection of libraries? This is I mean, we've had a few projects on the show where we actually like spoke to them about the work that they're doing. Sometimes they have these languages and I still don't entirely understand where Arkworks fits in. So maybe you can help me like maybe understand the landscape and where Arkworks lives.
Yeah, totally. So Arkworks is basically a collection of Rust libraries for implementing SNARKs and working with SNARKs. So what that means is that SNARKs have a lot of underlying components, as well as, when you're building applications on top of SNARKs, you need to build some infrastructure around that. So the goal of Arkworks is to make that infrastructure all modular and able to work with each other. So for example, if you want to implement a SNARK, you need to, have implementations of elliptic curves. Maybe you have to have implementations of pairings. You might need to have implementation of, some finite field FFTs and so on. And what Arkworks aims to do, maybe on this below the SNARK level, is to make it so that these components, you only implement them once, and then you can reuse them across different SNARKs or different implementations of SNARKs. So for example, all of the algebra infrastructure, which means elliptic curves, finite fields, FFTs, is shared across our implementations of the Groth16 SNARK, the Groth-Mahler SNARK, the Marlin SNARK. So all of these share the same infrastructure, so you don't have to implement it again and again. And then so once you have your SNARK, you want to build applications on top of your SNARK. And so on that front, like above the SNARK, in the stack above the SNARK, we want to make programming applications with SNARKs easier. So we have infrastructure for writing constraints and making that ergonomic.
So one of the things I'm not entirely clear on what Arkworks is. I've sort of tried to understand it as like a collection of libraries, but I wondered if it sort of falls into the category of a language. I think it would be really cool to hear from you how you place it in the landscape of the different projects that are trying to develop something similar.
So Arkworks is a collection of Rust libraries, and the scope of Arkworks is somewhat broad, but there's two primary, categories. Or two primary audiences. One is folks who are implementing very low-level cryptographic protocols. So you might think like, a SNARK or a signature scheme or some other low-level primitive. And the other audience is people who are implementing applications on top of SNARKs. So, people who are writing maybe circuits for, dark forest or something. So that's maybe the next audience. So people who are not necessarily very intimately familiar with the low-level workings of SNARKs. So for the first audience, the protocol implementers, what Arkworks aims to provide is a collection of coherent libraries that can be reused across projects. So for example, we have a very modular implementation of the algebraic components that you might encounter in protocols. So for example, elliptic curves, finite fields, fast Fourier transforms. These are all very core things for implementing SNARKs, as well as some of these are useful for implementing signature schemes and so on, right? And the idea for Arkworks is to make these things very reusable, so you don't have to re-implement the same code again and again. As an example, our implementations of the Groth16 SNARK, as well as the Groth-Mahler SNARK and the Marlin SNARK, all reuse the same underlying elliptic curve and finite field infrastructure. So there's no code duplication there. Okay, so that's the first audience.
Mm-hmm.
We aim to make their life easier. For the second audience, our goal is to allow people to program SNARKs in a way that's very close to programming, just natively writing your application. So for this, we've developed this infrastructure for writing constraints, which can be used to implement the SNARK inside that's used for dark forest or for sapling or so on, like whatever your cool SNARK application is. And you can think of this portion as more like sort of a domain-specific language, like a DSL, which is for writing constraints specifically.
But in that case, would you equate that with something like SIRCOM? Is it comparable, or did they work together?
Yeah, so our DSL for writing constraints is still, I guess, you're still writing Rust. It's just that, we make heavy use of some nice Rust features like traits and generics to make it so that, you're still getting, very good quality constraint systems out. So they don't have like unnecessary or inefficient constraints in there. But you have like all of the, whatever Rust offers, you can still take advantage of that. And we, as I said, we like heavily leverage generics and Rust traits as well as Rust macros to try to make this ergonomic and like as low effort as possible. But I think it sort of still sits at maybe a level below projects like Circom or Leo or Zinc or these other sort of or Socrates, basically these languages which are high level and are like very just targeted at SNARK constraint generation. So yeah, I think we sit a little level, like a level below that.
So if I understand correctly, you're trying to do two things. So one is for application developers who want to write something that uses SNARKs, many SNARKs are just going to use the same types of constraint systems, and they'll just be able to write Rust code that, for some constraint system, for some SNARK, it's going to execute the circuit that's desired. And then on the other side, you create tools for people to build new SNARK protocols that those two sides of things can be plugged together. And you have try to reach those both use cases with the same set of libraries.
Exactly. Yeah. And yeah, it's a good point about the modularity. So one thing I didn't mention was that, our goal is to make it so that you write your constraint systems once, but they're not like specific to a particular kind of SNARK. So, I write my constraint system and then I can use it with a Groth16 SNARK or with a Marlin SNARK or with a, Halo SNARK or, whatever the latest SNARK is. It should be easily, portable to, the constraint system shouldn't have to concern itself about, what is underneath it in terms of the SNARK.
So when you write something at the higher level, when you write higher level code in Rust that uses these constraint systems, and then you plug in a SNARK system like Groth16 or one of the other ones, what is the actual output? Is it the Rust compiler is going to take your code that's been fitted with this modular component and actually produce a binary that is executing the circuit, or is there some other output of the process that happens later on or earlier on in the cycle?
Right. So everything in Arkworks is implemented as a library, and it's as a generic library. So what that means is that, for example, the Groth16 SNARK will have a type parameter where you can say this is the kind of constraint. Like this is please plug in your constraint system here, and then I'll take over and I'll just leverage the interface of the constraint system to get out the constraints. And then, for an end user, you do have to compile it down to a binary, right? And at that point, you will instantiate all of these components. So you'll instantiate what elliptic curve is used underneath your Groth16 SNARK, what constraint system is being plugged into your Groth16 SNARK. And so basically, that's when it's all instantiated, and then you get out like a final concrete system.
I see. So, and that can just be embedded into larger binaries. But is there a goal of creating sort of self-standing proving binaries, or is that something that happens outside of the Arkworks ecosystem?
I think our goal is to implement the libraries, but I believe that Cello as well as Mina, what they've done is they've taken these libraries and they've compiled them down within and stuck them like within their specific binaries so that you can within their larger application context. And then they just call these libraries, whatever binaries we do implement in the ecosystem have been mostly just for our own experimentation and benchmarking purposes. But there's nothing stopping, somebody from writing a one-page, even Rust binary which just calls these methods on Groth16. It's very straightforward. Once you have your components, it's just like probably less than 50 lines to take in some user input and then spit out a proof on the command line.
I want to understand a little bit about what people would have done before there was something like Arkworks. Like there are existing projects. I kind of mentioned Circom, you mentioned Leo, you mentioned some of these others like Socrates. What were they doing? If you wanted to use what they have, what would you have had to do as an engineer, as an implementer here that's different than what you can do now with Arkworks?
Right. So yeah, I guess it depends on your audience. So I think like Socrates and Zinc and Leo and all of these languages, their aim is to sort of provide a fixed package to the end application developer. So the application developer shouldn't have to worry about, what kind of proof system am I using and how is this going to be, how efficient is it going to be. They just give you like a compiler, and at the end, you plug in your input program and it'll spit out your final proof or your parameters or whatever, right? So that's, I guess, these end-to-end systems, and their goal is to provide a very high-level API to users who are not necessarily like technically proficient. They might be, programmers, but not necessarily cryptographically trained. And then there's like a separate set of libraries and tool chains which aim to target, I guess, more like SNARK developers and protocol developers. And in this category, you'll find libsnark, you'll find the Bellman ecosystem, you'll find, as well as Mina's, I think, snarky ecosystem. Forgive me if anybody out there, if I'm not naming a project. But yeah, so these libraries, I guess libsnark was the first one, and it offered a C++ interface. And I guess that's the problem with C++ is that when you try to get this high level of generic and modular code working together, it can become a bit hairy with the template metaprogramming and template instantiation errors. So since then, I guess people, and also because of memory safety, so people have moved on to memory-safe languages such as Rust or OCaml or Go, where you can still like maybe leverage, I guess, modern programming idioms without having to worry about memory safety and those kinds of bugs. So I guess, Bellman, I guess, was the precursor, ancestor to the ZXC codebase. And we forked it off from there just because we needed to add some more flexibility for our research purposes. And since then, we've leveraged that additional flexibility to make the ecosystem more generic. But the Bellman ecosystem is still a great source of libraries for developing your own applications. Is that we took a few different trade-offs there. And OCaml and the Go ecosystems, I think, they serve a different niche. I just like programming in Rust, so.
But I'm curious about that connection to Bellman. Like, did you take a lot of those initial libraries and bring them in? Did you write everything from scratch?
Yeah, so a lot of our, especially like the algebraic infrastructure, so the elliptic curves and finite fields, it started off as a fork of the equivalent libraries inside the Bellman ecosystem. Basically, at that point, I believe like Bellman was less than a year old, so there was still, a lot of the interfaces were not maybe as fully baked as they are now. Since then, there's been a lot of work, and now they're very nice interfaces. But I guess at that time, we needed a little bit more flexibility and some more knobs to tune inside their interfaces, which they didn't provide. So we took their code base and excellent code base, and added those knobs so that we could tune for our initial requirements in the ZXC paper. But since then, they've proven useful, as I said, I think, for other projects as well. But a large part of the code is of this core, like the algebra code, is shared from the Bellman infrastructure.
Touching on the algebra portion of things, it seems like a lot of people have tried over time to create interfaces and programming language objects that encapsulate those same mathematical objects. How have you found the process of trying to encode those things in the Rust language? Are there edge cases? Does it work cleanly?
So I don't have a lot of experience perhaps with other approaches, but in my experience in Rust, it allows you to very easily compose a lot of different objects. So for example, a very fundamental object is elliptic curves, right? These elliptic curves, they come associated with, two fields or two finite fields. One is the base field and one is the scalar field, right? And they have some associated arithmetic. There's some formulas which go into, add points on elliptic curves. So what you ideally want to do is you want to write your arithmetic just once, right? The elliptic curve arithmetic just once, no matter what kind of curve it is. So as long as, it's a short Weierstrass curve, I only want to implement the point addition and point doubling just once. And I shouldn't have to care what the kind of underlying field is at all, right, for the base field. And what Rust allows you to do is to just easily add a generic parameter, which can say, so this elliptic curve is generic over any kind of field. I don't care what the field is, as long as it implements some basic addition and multiplication and inverse operations. And Rust allows you to express these constraints very easily via Rust traits. And so what this means is that now when you want to implement a new curve inside Arkworks, you can take this existing one-time implementation of the curve arithmetic, and you can take the existing templates for your field arithmetic and just combine these. And so what it ends up being is that implementing a new curve takes just maybe 100 lines of code. And compare this to perhaps hand coding your implementation. You have to re-implement all of these components again and again, and that would probably span over 1,000, 2,000 lines of code with potential for bugs and so on.
Have you found that, for the example of elliptic curves, that people are taking libraries for elliptic curves that are written outside of the Arkworks ecosystem and wrapping those and then bringing them into that same trait wrapper?
So not yet. I think that might become an option in the future. There are a few paper cuts involved in that our traits do require you to implement a lot of subtraits. So it's a little bit of an overhead to actually implement our field and curve traits. But what we do enable is that we already have implementations of some generic finite fields and generic elliptic curves, so that when you do want to implement your new curve inside Arkworks, you don't have to really worry about the efficiency or worry about redoing arithmetic. But it is a goal of ours in the future to enable people to easily take arithmetic implemented in, I don't know, like the Dalek libraries, or maybe in the Bellman libraries even, and easily use those implementations with existing Arkworks infrastructure. So that's a goal. We haven't yet found time to devote to that, but that's certainly on our radar.
Do you give tools for people to punch through the abstractions if they need to, if they want to rely on a particular property of a field or of a curve that they use for optimization in a protocol?
Right. So there's always it's a good point. There's always this trade-off between abstraction and often efficiency, right? Oftentimes, if you specialize to a particular kind of field or modulus or curve, then you can get efficiency improvements, right? So that option is certainly available inside Arkworks. So if I don't care about abstraction, then I can just say, okay, just give me, for example, the BLS 12381 curve, and I'll just use that. That's what I'll use in my protocol. So I'll optimize my protocol around that. And so we I guess, do allow you to do that. That being said, our existing implementations of the SNARKs, for example, are all generic. So they can't quite directly leverage those properties of special properties of elliptic curves. But what we do allow is that when you're implementing the curve itself, if you have a elliptic curve which has some special properties, so for example, if your elliptic curve has very efficient kinds of scalar multiplication. So there's one method called GLB multiplication, which allows you to speed up scalar multiplication, which is a core operation in a lot of protocols. It allows you to speed that operation up by quite a bit, right? So there's some implementation effort by contributors from Cello, which allows you to generically sort of specialize the scalar multiplication code for curves which support this GLV optimization, so that when at the higher protocol level, you don't have to worry about, does my curve support GLV optimization or not? It just transparently gives you that efficiency boost. So we do. We're always trying. I think our goal is to allow, at each level of the stack, allow people to apply the optimizations that make sense within the stack in a transparent manner, so that at the high level of the stack, you can take advantage of it without having to worry about whether it exists or not. I hope that answers your question.
Yeah, it does. It does well.
I want to talk a little bit about the general cryptographic community and their use of Rust, because when you're talking about this, I keep thinking what if some of these implementations have been done in a different language, but they should be included? Does it mean that you need to re-implement the entire thing, or is it something that could actually be shared? Or do you just see that most of the crypto community right now are moving towards Rust, so maybe it won't be a problem?
Yeah, so in my mind, I think sort of Rust is the perfect language for implementing cryptographic protocols for two reasons. So one thing I mentioned earlier was that unlike C and C++, Rust has memory safety, right? So which means that if I have if I'm indexing an array incorrectly, I won't accidentally access your secret key and reveal that to the network, what happened with similar things happen with Heartbleed and so on. And this is like an essential property for cryptographic protocols, right? Because these are often the most security sensitive portions of, especially in like blockchain protocols. So that's one property. But like, you might say there's a lot of other languages which are also memory safe. But I think the nice thing about Rust is that it hits the same performance profile that C and C++ aim at. So you get like the benefits of C and C++, namely the performance, without the downsides of the lack of memory safety that you suffer there. So in my mind, I think the optimal approach would be to design your protocols and design your core primitives inside a Rust based library. Could be, Arkworks, could be Bellman, there's other libraries as well. And then if you want to interface with it from another language, let's say your final application is developed in Go, I think the best way would be to just expose a simple interface to Go of the high-level protocol functions. And then you can just call these methods from Go. So in Go, you're not implementing your heavy cryptographic machinery, which can be difficult to optimize predictably, right? But then at the application level, you're still benefiting from whatever benefits Go provides you, namely ease of deployment and so on.
But in this case, you're talking more like from the low level, being in Rust, going upwards, like to the application level. But what I was actually thinking was like older implementations that weren't done in Rust. What does it mean for them to be included in Arkworks? Like, is there a way to do that? Or is it like something where you should not be bringing in kind of different languages at that low level? It should all be in Rust in the Arkworks setting.
Yeah, basically, I guess the older implementations would probably be in C and C++. And I guess the nice thing about Rust is that it has a very good story about interfacing with C libraries. So, and by extension, C++. So the idea there would be, if you wanted to reuse some existing component, let's say you implemented your state-of-the-art SNARK in C++ and you didn't want to rewrite it in Rust, what you could easily do is provide a C wrapper around your C++ library and then link to that C wrapper from your Rust code inside Arkworks, and then reuse Arkworks for the rest of your application development if you wanted. So that's certainly possible. I would not recommend that. I think, for example, one of the original approaches that Sean investigated while developing Bellman was to write a wrapper around libsnark. I think, it just gets a bit hairy, especially when you're working with C++, it gets a bit hairy. So he opted for the pure Rust approach in the end.
Is there a lot of code that goes into writing SNARKs or the algebra, or is it mostly like thinking work that then turns into 100 or 200 lines of code?
So I think for the SNARK world in particular, if you're developing SNARK protocols, I think most of it is in the research phase and like the math and computer science phase. And then implementation, I wouldn't say it's trivial at all, though. It's that, going from what is optimal for presenting, in a paper is different from what's efficient inside an implementation, right? So oftentimes what you'll see is that you'll say something in the paper, and then when you're implementing it, for the purpose of the implementation, you have to optimize it. So there's like a lot of effort which goes into the code, but I would say that those 100, 200 lines of code have a lot of cryptographic thinking behind them, and then implementation, you have optimizations at the protocol level that also appear there.
So that code would become really, really dense.
Yeah, so I guess maybe compared to some other domains, a lot of protocol, like SNARK protocol code is, there's a lot of information within each line. I guess I would say that.
What kind of experience do you try to create for developers who are working with Arkworks?
I guess there's two audiences, right? So the protocol developers and the constraint and the application developers about the SNARK level. So for the protocol developers, I think, our aim is to make it so that you can go from the paper to code in, without worrying about, did I do this step correctly, or is this step secure? To basically provide secure defaults that the protocol developer can come in and just use them while still ensuring that, security without losing efficiency. So by choosing Arkworks, you might get security, but you don't want to sacrifice performance, and that's sort of, we try to balance both of these aims. At the higher level, the application developer level, our aim is to make sure that even if you're maybe not a SNARK expert, you can still write constrained systems and then applications atop those in a way that's, even if you're not cryptographically trained, it should not be like, you're spending all of your time just wondering, is this secure? Basically provide you with efficient defaults. And I guess at both levels, we want to provide efficient and secure defaults that folks can use. But obviously, what we assume of users is slightly different at each level.
Like earlier on in the conversation, you actually defined what groups you were targeting, but can you just repeat what those are? So you sort of mentioned for protocol devs, but are you actually, would you picture like an application developer using Arkworks directly, or are they going to have to go through something to interact with it?
Right. So the two audiences that I mentioned earlier were people who are developing cryptographic protocols directly. So maybe implementing SNARKs or implementing your new signature scheme or some other primitive of the sort, right? So that's group one. And the other group is people who are not, developing cryptographic primitives, but other applications using SNARKs. So for example, if I'm implementing dark forest, I might not know, what is the exact security property of this SNARK and, what kind of efficiency it guarantees me. I just want to write my constraint system and then use that within my, people who want to use SNARKs as a tool, not as, something interesting in and of themselves. So we target both of these folks, and I guess your question about can somebody just pick up Arkworks and use it within their application, that is more relevant to the second group of people, the application developers. And I think our aim is to cater to those folks also. Obviously, because our interface is a little bit lower level than something like CIRCOM or Leo or Zinc or any of these languages, right? It's a bit more starting cost, but we do by having that initial starting cost, it does allow you for more avenues for optimization. So, for example, I think in Socrates there is not a way to. One common trick in SNARKs is to, instead of if you have some expensive computation, all you need to do is check the computation instead of doing it. Let's say I have a factorization, right? It's very easy to check that the factorization of a number is correct, right? You just multiply the factors together and you check that it's equal to the final number, right? But actually computing the factorization is very expensive, right? And I want to prove to you that I know the factorization of some number, let's say my RSA key, right? All I need to do inside the SNARK is multiply the numbers together. I don't need to factorize them for you, because you don't need to factorize them either, right? So the computation inside the SNARK is much cheaper. Now, what Arkworks allows you to do is to express these kinds of optimizations that are specific to SNARKs at a low level, while maybe high level frameworks don't necessarily expose that ability to folks. So yeah, that's so if you're an application developer aiming to use Arkworks, you are working maybe at a slightly lower level of abstraction, but it does allow you to get more efficiency for your final program.
Do you mean in the sense that it allows application developers to think more clearly about the proving and the proof checking side of their protocols? Yeah,
it gives them maybe a clearer insight into what the code they write, what that will translate into in terms of number of constraints and how to optimize the size of the resulting constraint system.
I want to go back to one of the things you said earlier about making it really easy to translate from mathematical papers into code. That sounds really striking to me because the notation that you have in mathematical or cryptographic papers is very different from the code that people would usually write. I'd imagine it's a large source of errors. Could you elaborate a bit more on how you achieve that, or where it really works well?
So one example is that a lot of, especially in the SNARK literature, a lot of the protocols are written in terms of an abstraction called a prime order group. A prime order group is just some object where you can add things and subtract things, and there's a concept of a zero, right? So something plus zero is equal to something, right? So a lot of protocols are defined abstractly in terms of this group abstraction. And what we implement in Arkworks is a trait which basically captures this group abstraction. So it implements addition, it implements subtraction, and it implements some notion of a zero, right? So when you're actually writing a protocol from the high level pseudocode to code, you don't have to worry about, how am I going to translate this group abstraction? You just use this group trait, and then you invoke this addition and subtraction methods on it as appropriate. So that's one place where, for example, we allow you to not have to worry about how am I going to translate my pseudocode to code. There's other places as well, like we have abstractions for FFTs and polynomial multiplication. Like your protocol might say multiply two polynomials, right? And you don't want to worry about how I'm going to do this polynomial multiplication because there's lots of ways to do it efficiently, lots of ways to do it inefficiently. What you just want to do is use the efficient default. So we have abstractions which just say take polynomial 1, polynomial 2, multiply them. Yeah, so it matches the high-level description again exactly.
You actually mentioned a couple projects that are using Arkworks. So you mentioned that it's being used within like Cello's sort of larger structure, potentially with Mina as well. But where else, like who are the users today?
Right. So I guess there's two categories of users again. So one is like industrial users who are taking SNARK protocols and deploying them in practice. And within this category, I think Cello and Mina already fall. I think other folks are looking into it, but I think maybe Algorand is looking into it as well, but I'm not entirely sure. Alio also, they're using a fork of the sort of a prior version of the Arkworks code base, and they're also using it. I guess Alio is a ZXC implementation, so it makes sense that we use the same infrastructure.
Totally.
I can say that Web3 Foundation is using it for BLS aggregation.
Awesome. Yeah. So there's a lot of, it's kind of difficult to know who's using your code. We don't have that telemetry infrastructure. I don't think I want to add it either. But I think there's like some nice industrial adoption at, I guess, all levels of the stack. The protocol implementers, as well as I think Cello and Alio, they have constraint system implementations. It's at a couple of different levels of the stack. And then there's the research users who are using it for their, when they develop a new protocol to experiment with their efficiency and figure out what the performance is. So I know, a few groups, both obviously within Berkeley, within Alessandro's group, but also outside who have used the Arkworks code base for implementing the protocols.
Cool.
So you're at Berkeley, you're in the academic community. Have you found Arkworks to be a useful teaching tool, or do you think that it could be used to teach students about zero knowledge proofs?
I think certainly it can be useful to, I guess for teaching, the requirements are kind of slightly different, right? You don't really care about performance. You just, want to make sure that it's very simple for the students to develop, because they're already learning a lot of new things. So the Arkworks, there's certainly a slight learning curve to Arkworks, even along with learning Rust. So for teaching, I'm not sure it's perhaps yet the best tool. That being said, I did in a past course that I co-taught use Arkworks to showcase some simple constraint writing tutorials and so on. But I think it needs a little bit more work before it's appropriate for use inside an educational context.
I see. You'd rather have something that was just really easy to use, but didn't focus on a lot of those other aspects, like performance and allowing people to optimize and swap out components.
Yeah, I guess if you're an undergraduate or even at a graduate level, like early graduate level, there's already a lot of background that you need to pick up, like for SNARKs before you can start using them. So maybe adding Arkworks and Rust on top of that can be slightly difficult. Also because like in an educational context, I think you can expect most students to already know Python or maybe C or C++, but I think Rust is still sort of getting there in terms of popularity. So it's like an additional stepping stone for people to pick that up along with Arkworks.
I had a question a little bit about how you picture this being maintained going forward, because you mentioned earlier on that this is a project coming out of your work at Berkeley, but it's not a company, I guess. And I'm wondering kind of like, what is the strategy for actually keeping this going after, I don't know, say you step away from it? I'm not saying you will, maybe you never will, but like, you know what I mean?
No, that's certainly a very good question. And I think one that we haven't yet had to think about, or probably we will have to think about it also because I'm going to be graduating soon. So certainly something that I think I want to like keep contributing to it even in my off time, whatever I do after graduation. But yeah, it's a good question. We haven't yet thought of it, fleshed it out fully. Probably we might, if there's ongoing industrial adoption, then might have to flesh out some ideas on maintenance and funding and so on. But we haven't had those conversations yet.
Because actually this sort of brings up a bigger topic, which is like when you don't have, in this case, like Arkworks is it's a collection of libraries. It's something that's going to be used by projects that do have value in their tokens, or maybe there's going to be businesses that are potentially going to use this. It kind of goes back to the general open source development question.
Exactly.
Of where do these things end up living, and who maintains them, and who's going to take care of them if they are actually key to something, especially when you can't necessarily monetize these. Like these won't have a token, although they may be underlying tokens.
Yeah, certainly I think a very difficult question in the open source space, and that a lot of projects outside cryptocurrencies, within cryptocurrencies are facing. Just, when you're maintaining this open source common good, then how is it funded? I mean, I will say that there's a lot of, even beyond me, there's a lot of excellent students at Berkeley who have been, taking over more and more responsibility of maintaining different parts of the ecosystem and, helping with fixing bugs, adding new features, cleaning up code. So there is certainly, an ongoing supply of maintenance from Berkeley students. That it's a good question on how to fund these open source utilities, which are common goods outside of the cryptocurrency space, especially within the cryptocurrency space. I think maybe, I don't know, foundation grants could be one option, or honestly, I haven't looked into the space too much. I haven't thought about it too much. I don't know what the state of the art is.
Yeah.
So
I'm wondering if you know of any other projects that come from a more academic context who have made that transition. It's okay if you haven't, but I think there's also just a general call to the listeners, if maybe they've heard of something like that, because I'd be curious to hear how projects like this can be incubated and let out into the wild in a really healthy way.
Yeah, so I think in terms of other code bases within the SNARK ecosystem, obviously there's the libsnark, right? Which started off as a code base that Alessandro and Madars and co were working on when they were grad students at MIT. And since then, it was initially used in the first deployment in Zcash. It was used, I think, back when Mina was starting up, and still it's used as a backend in Socrates and such. But I think what's happened there is that different projects have, as maybe some of the maintenance of libsnark has, or the effort in put into updating or keeping libsnark up to date with the newest developments has slowed down a bit. I think other projects have forked libsnark for their use cases and added whatever things they wanted in there. I think there's value in having avoiding that for Arkworks, just trying to make sure that all of the different editions all work together and all sort of in the same ecosystem instead of forked ecosystems. But yeah, I guess in terms of other projects, I think all the other projects, as far as I know, Bellman is funded by Zcash. Worked on by Zcash folks. The Go Gurvy libraries, I think they're worked on by Consensus folks. I think usually there's a big company backing these, big or small company, some company backing these. I'm not aware of too many open source projects in the sort of foundational SNARK ecosystem, I guess, or these foundational layers. So maybe I guess one is the Dalek libraries. I don't know how they handle maintenance and funding, but they're also a primarily open source project, which doesn't seem to be, fundamentally tied to just one company or cryptocurrency.
Maybe this is a call to action for everybody who's loving the crypto bull market to help support all of the open source technology that's maintained by one guy in Montana that supports the entire internet.
Good move.
I think it's interesting that as an ecosystem, you're targeting these two sides. So one is the research side and one is more of the application side, because what we've seen so far is mostly experimentation with SNARKs on, I'd say, the research side of okay, here's a way we can make a proof. What are we proving? Let's figure that out later. But I think now we're going to want to see a shift to people actually using zero knowledge proofs and seeing that change in direction. How do you view that transition? Is that undergoing? What stage are we at?
Yeah, certainly. I think we're moving from SNARKs as a tool for specialized groups within snark-focused companies like Zcash with the, they were the sort of pioneers of snarks in industry. But Zcash, with its specific circuits for just payment, I guess Cello has, snarks for their aggregating of signatures. Mina has their snarks for recursive composition. So I think like the sort of, snark 1.0 era was very application-specific snarks. And I think the next level will be snarks for general-purpose computations and general-purpose applications. So I think we're seeing that already with sort of maybe this latest proliferation of snark languages like Circom, like Zinc, like Leo, right? Where the aim is to bring in the average developer into the snark world. And I think that's where sort of one of the next exciting frontiers is to sort of democratize snarks and programming with snarks. And I mean, that's not to say that, the research side is going to stagnate. I feel like definitely within the last year and like post Halo, there's been like a lot of exciting developments on various properties of snarks such as recursive composition. But I think what will eventually happen over maybe the next 3-4 years is that the research side will settle down a bit. We'll find some good snarks and performance snarks which sort of fit our use cases. And I think the next step the really exciting step will be making the average person able to use snarks. And I think, that's personally what excites me. As like when you're in academia, you're always like, oh, here's a cool idea. And then you sort of, you wonder if it's ever be useful for anybody. But I think snarks have jumped this academia industry barrier. And now we're going to be seeing, I hope, a lot more adoption. Does that answer your question?
Oh, definitely. Now I just have more things to ask. Exactly that point that you said about democratizing access to snarks and bringing it to the average developer. Do you think that's going to happen on blockchains, on smart contracts, or do you think of other places where snarks are going to be really useful?
I think this democratization will start with cryptocurrency. I mean, it's already started with cryptocurrencies because I feel like snarks are sort of, blockchains in general, like the killer application for snarks, right? There you have, a lot of nodes that need to verify a lot of computation. Is not like a single source of truth, and that's where you need this sort of privacy and integrity properties that snarks offer, right? So I think blockchains will perhaps pave the way forward for snarks to be used in industry. I think after that, we will see more applications of snarks perhaps outside the blockchain space and maybe in I think the next deployments will probably be in places where privacy is important. So maybe healthcare or finance or I guess, standard finance, classical finance. But I think that is a bit more far off in the future just because, those are established industries and perhaps they have more inertia to adopt new technologies. Yeah, these blockchains are just, they will the benefit is that they're providing a lot of financial incentive for snarks to become a sort of usable technology beyond just a research tool.
Cool.
Bringing it back to Rust, one of the things that I think a lot of people are really excited about with Rust is WebAssembly. So compiling Rust programs to WebAssembly where they can be used in the browser or even in smart contracts or even, as a cross-platform operating system execution tool. How do you think about the interaction between WebAssembly and Arkworks? Is it something that you target or optimize for?
Yeah, certainly. So Rust is a very nice story about compiling down to WebAssembly, and we try to take advantage of that as much as possible. Our code base is all sort of no standard friendly, which means, which is technical speak for that, it can compile down to WebAssembly without too many problems. So we're certainly WebAssembly friendly. I think some folks have done some toy projects with using WebAssembly, like Arkworks compiled down to WebAssembly. But yeah, I would be very excited to see somebody, using Arkworks to do snarks in a browser or something.
Have you done any research into the code sizes that are produced when compiling Arkwork-based applications?
No, I haven't. But I think the nice thing about our framework is that because it's all generic, right? What that means is that when you do compile it down to like your final application, which uses a particular curve and a particular snark, all of the things that you don't use are entirely stripped out. So you don't pay for what you don't use. So that should help with that. But I off the top of my head, I have no idea what the actual costs would be.
Okay, you don't pay for what you use or what you don't use, even in the code size.
Yeah.
I have a question for you, Rob, and for you, Pratyush, because when we talk about like Rust and WASM, and I mean, this just reminds me of a lot of conversations that I had with like Frederick being on the show and kind of bringing it back to Parachains and Polkadot. Since you're here, I have a quick question. Like because it's written in Rust, I'm assuming it's like network agnostic. It can be like used in anything that touches Rust. If you can deal with Rust, then you can deal with Arkworks. I know that there's a few privacy parachain projects coming out. Would they be able to use something like this as is, or would they need to have something done for it to be used in a parachain context?
My understanding is that they could just use it. I think one of the difficulties is that we expect, or at least the toolkits, the SDK, Cumulus, and Substrate that we provide for writing parachains expects a no standard library environment. I'm not sure if Arkworks requires the standard library. I imagine it uses the standard library more for things like memory allocation, which you don't necessarily actually need the standard library for. But barring that specific blocker, I think it could just be used by any kind of parachain project
out of the box
to implement whatever zero knowledge system they wanted to.
Right. Yeah. So Arkworks is no standard friendly. So as you say, most of the requirement is just in allocating memory. So yeah, you can just plug it in these environments.
Interesting.
Cool.
Well, I figured since you're here, I might as well mention it.
Yeah, I'm glad to bring it up. I mean, I'm super excited. I didn't want to barge in. I'm a host here, but it's definitely a lot of cool stuff you can do with this project.
Cool. Well, listen, Pratyush, I want to say thank you so much for kind of walking us through Arkworks and helping us to understand what it is, how it's already being used, maybe how it can be used. I do wonder, is there any sort of call out to the audience you might have about contributors or like anything, if people want to get involved, some way for them to participate?
Yeah, definitely. I think we're always looking for contributors at like all levels of experience with cryptography as well as with Rust. We've tried to label our issues with, which are beginner friendly and which are not. So yeah, if anybody's interested, just hop on over to our GitHub organization. So arkworks.rs is where it's at. And ping me on Telegram or Twitter or wherever. And I'll be more than happy to help people get involved and start contributing.
Cool. Do you have any sort of community chat or anywhere like the Telegram group?
Yeah, we do have a Telegram, which
Okay.
I think we can put in the show links.
Sounds good.
I wanna join.
Cool. You got a new member over here.
Awesome. Already.
Cool. All right. So thank you, Rob, for co-hosting.
Thank you, Anna, for hosting.
And Pratyush, thanks so much for being on the show again.
Yeah, thank you guys so much for having me.
And to our listeners, thanks for listening.